Alright, so this is the video I got to redo. Pesticide claims to kill, I don't know, 65% of all cockroaches every 22 minutes. There's a similar example. Write the model. It is decay, so I'm going to plug into P times 1 minus R to the T. And I don't yet know the principle. It hasn't been told to me yet. So 1 minus 0.65. And every 22, the T over 22. Okay? 1 minus 65 hundredths is 35 hundredths. There's your model. 2 is to convert the T from every 45 into every minute. What I do is I bring that 1/22nd inside, and then I just go push some buttons on a TI-84. 0.35 rooftop to the 1/22nd power to the 4th decimal place is 0.9534. All right, I'm going to leave everything about 3 the same, except this is the equation. In 3, you're told you have an initial cockroach population of 10,000. And by doing that, I would just replace P with a 10,000. And I forgot my T variable there, 0.9534. Don't forget about T. And the question is when will there be 10 of these suckers? So 10 is 10,000. And this is a calculator problem, straight up Y1, straight up Y2. Zoom 6 as always. Going to look a little higher. I don't have to look up to 10,000. I just have to look up to above 10. So let's say 15, maybe 20. Let's go to 20. And the x-axis here is only going out to 10 minutes. That's all it's doing. Time was in minutes. It's only going out 10 minutes. So I'm going to say the x-max is 200. 200 minutes. I'm just going to see if anything happens. There was. I don't think I actually looked up, did I? Make that a 15. Pretty tired. Been a long day. There's my answer. Second trace. 5. Intersect. Enter, enter, enter. 144.75 minutes. And I'm just going to say 145. About 145 minutes. According to your model, when will the cockroaches die? Even though these are life forms, they're going to die when there's less than one of them. Okay? That's just the deal. If there's less than one and you're actually talking about cockroaches, well, that'd be 0. So I'm actually going to say that the equation itself is less than 1. 1 is less than 10,000. 0.9534 to the T. Now, I can't actually do that in a calculator, but I can change that 10 into a 1. I don't have the inequality symbols. At least they don't work the way you think they are. They're there. Anyways, that's what I'm going to look at. I've already played with my Windows some, so I'm just going to hit graph. See if there's an answer. There might be. Second trace 5, enter, enter, enter. And it found it. Roughly 193 minutes. So the time has to be greater than 193 minutes. That's how I'm going to answer it. It's an inequality. Inequalities are answered with inequalities. This is actually the whole reason I'm remaking this video. I completely screwed this problem up. I don't know why I did it. I was keying out the originals and I noticed, and I just remembered I made a mistake. I'm going to do a sub n is -2 times 5 to the n minus 1. That's all I'm going to do. First 3 terms are simple. If you want a sub 1, you plug in a 1. If you don't know how to do that, do it in a calculator. It should be -2. The reason it's -2 is because your form for these is a sub n is the first term a sub 1 times r to the n minus 1 power. So there's kind of a lineup going on. A sub 2, if you don't understand your form, just plug a 2 in, and it'll spit back a -10, because 5 times -2 is -10. A sub 3 without plugging in is going to be -50, because I'm multiplying by 5. That's the multiplication that makes it geometric. All right, part 2, find the sum of the 10th through 12th terms of the sequence. The easiest way to do this one, because there's only 3 things, is to legit find a sub 10, find a sub 11, find a sub 12, and add them together. That's the easiest way to do it. All right? There's a harder one down here. We'll use a formula, but you don't have to use a formula for this one. So a sub 10 happens when I plug a 10 in. And I have no idea what that is. It's going to be absolutely gigantic. And if I don't know that 10 minus 1 is 9, I just literally type 10 minus 1. It's a big number. -3906250. Now, if I want a sub 11, I plug an 11 in. And I'm just going to go up here. I'm going to change that 10 into 11. I could use a storage feature too. -19531,250. And now I'm going to replace that 11 with a 12. And a sub 12 is -97656,250. And because there was only 3 things, this is probably the easiest way to do this problem. So now I'm going to add these pieces together. And hope I didn't miss any numbers. And there's my sum. The sum of these 3 things is -121,093,750. Big stinking negative number, isn't it? That's the easiest way to do that one. All right. Consider the sequence -3, -9, -27. Write a rule. So we're following this form that the nth term is the first term a sub 1 times r to the n minus 1. That's my rule. Plug crap in. Your first term is -3. This is a sub 1. Oh. Almost did your problem for you. There we go. This is the first term. Now r is found by taking the second dude and placing it over the first. And you get 3. So this r is a 3, and the exponent is n minus 1. There's your rule. Number 2, find the sum of the 5th through the 12th terms. I would have to do a sub 5, a sub 6, a sub 7, and I want to say that I could do a sub 5 plus a sub 6 plus a sub 7 plus a sub 8 plus a sub 9 plus a sub 10 plus a sub 11 plus a sub 12. It's actually quicker to use a formula. You need to understand that. It's quicker to do a formula. And for a geometric sequence, which is this formula is also given to us by Gauss, the one I gave us the last funny looking one, the sum of n things is a sub 1. That's kind of special on this one. 1 minus r to the n over 1 minus r. This is the first term that matters. And the first term that matters is actually a sub 5, because that's where this thing starts, okay? So I do have to go off the side and find a sub 5. I have to do it. So I take the little rule that I wrote, negative 5, parentheses 3, rooftop to the 5 minus 1, and I just push the buttons. It's negative 405. All right. How many things are there? Well, we've done this before. N is 12 minus 5, add 1 back. 12 minus 5, add 1 back. That makes what? 8? So let's start plugging some stuff in. We're finding the sum of 8 pieces. It is the first term that matters, negative 405. 1 minus the ratio. There's your ratio. When I made this sequence, I realized I was multiplying by 3. And that is going to be raised to the 8th power over 1 minus r. That's how you get your answer. Negative 405, set of parentheses, math, num, numerator over denominator. 1 minus 3 to the 8th power. Down low, 1 minus 3. If you don't know that's negative 2, master set of parentheses, and there is your answer. That's it. It ends up being negative 1,328,400. All right, so that's done. I got one more video I got to make, and then I'm going to leave for the day. I was going to work on a key before I left, but I said I noticed I screwed something up, so I had to redo a video. It is what it is.